Hello chemists, I am going to walk you through the change of state calculations assignment that you will be having to do within the next couple of weeks. And on the top of your paper there is a variety of useful information and reference values. So first are your formulas. Q equals mc delta T. You will be using that one if you do not have a change of phase state. So if you are heating or cooling water, liquid water, or vapor, or solid ice, because all of our examples will be working with water, you will use mc delta T, where Q is the heat energy in joules, M is the mass of your sample, C is the specific heat, which over here you will see varies depending on if you have water or steam or ice. And then your delta T is your change in temperature, and your delta T will be the final temperature minus the initial temperature. The other two formulas will be used if you are, for example, the Q equals m delta H sub F. That is the melting or freezing of a substance, in our case water, and in that case you would use the heat of fusion of water, which is 334 joules per gram. And so for this formula you would just take your mass, multiply it by that number, units cancel so that you only have joules because all of our masses will be in grams. That's how you use that one. Similarly, the Q equals m delta H sub V is when we have vaporization or condensation, and you would get your Q, your heat energy in joules, equals the mass in grams multiplied by 2,257 joules per gram. Grams cancel, you only end up with joules. Joules will be our unit of heat.
Mr. Paul to the guidance office, Mr. Paul to the guidance office.
And so when we are heating and cooling a substance with no phase state change, you use Q equals mc delta T, where Q is your heat energy in joules, M is mass in grams, C is your specific heat, which will always be provided for you, and delta T, change in temperature, final minus initial. And there are our other formulas. So if we are melting or freezing something, we use Q equals m delta H sub F. Vaporizing or condensing, we use Q equals m delta H sub V. So that's your background information. It's simple plug and chug. We won't get too deep into the intermolecular forces at hand, but I will mention it as we go through. Also, make sure that you are using the correct specific heat value for liquid water or steam or ice. It's easy to make a mistake if you're in a hurry, you're getting in the groove of things, you're like, okay, this is easy, and then you use the wrong value. Another thing that you should keep in mind is that if you are asked to calculate how much heat energy is required to convert a certain amount of ice at a specific temperature to steam, you can't just do the calculation in one big step. You have to go stepwise and do a series of calculations. And so you have a heating curve for water as a reference. And so in order to get from ice up to steam, you can't just jump straight there. So first you would have to heat your ice up to 0 degrees Celsius. That would take heat energy. And then you have to apply and add more heat energy to overcome the intermolecular forces of those water molecules to go from the solid state to the liquid state at the same temperature. So you have to heat, in this case, let's say -30 to 0 degree ice would take a certain amount of heat energy in joules. And then to get from 0 degree ice to 0 degree liquid water would take another value of heat energy in joules. And then heating that liquid water up from 0 to 100 degrees Celsius would take another value of energy in joules. And then to get from the point where you have 100 degree water to the point where it begins to vaporize would require another input of energy. And then to heat that steam from 100 degrees beyond would take more energy. So there will be each step that you would have to calculate if you were going from ice to steam. And that is what we will be doing together right now. So, first step. What is the heat energy in joules required to convert 1.0 gram of ice from negative 20 degrees Celsius to 0 degrees Celsius? So since we are not having a phase change, ice to ice, we will use Q equals MC delta T, where we take the mass, which is 1 gram, and the specific heat of the ice, which is 2.09 joules per gram degree Celsius, and we multiply that by the change in temperature delta T, final minus initial. So 0 minus a negative 20 is 20. And then you just multiply. The gram unit will cancel, the Celsius unit will cancel, and we are left over with only joules. And we have 41.8 joules. Don't worry about sig figs right now. I know a lot of you are breathing a sigh of relief. That's okay. So then the next step. So how much heat energy in joules would be required to convert that 1.0 gram of 0 degrees Celsius ice to 0 degrees Celsius liquid water? In this case, we do have a phase state change, and so we are going to use the Q equals M delta H sub F. We're going to take that mass, 1.0 gram, multiplied by the value we have at the top of our paper as a reference, 334 joules per gram. Grams cancel, and we end up with 334 joules. The third step to this would be to calculate how much heat energy in joules would be required to convert 1.0 gram of 0 degrees Celsius liquid water to 100 degrees Celsius liquid water. There is no phase state change, and so we will use Q equals MC delta T, and we just plug it in there and chug away with our calculations. So we still have 1.0 grams, 4.18 joules per gram degree Celsius is the specific heat of liquid water, and then we have a temperature change of 100 degrees. Multiply all those together, we have 418 joules. For the fourth part, we are being asked, what is the heat energy in joules required to convert 1.0 grams of 100 degrees Celsius liquid water into 100 degrees Celsius steam? We do have a phase change right there, so we will use the Q equals M delta H sub B, and we have 1.0 grams multiplied by the value provided to us for the heat of vaporization of water, which is 2,257 joules per gram. Grams cancel. We end up with 2,257 joules of heat energy required to convert that 100 degree Celsius liquid water into 100 degrees Celsius steam. And then part E, what is the heat energy in joules required to convert 1.0 grams of 100 degrees steam to 200 degrees Celsius steam? No phase state change, so we use Q equals MC delta T. Q equals 1.0 grams, and the specific heat of steam, 2.09 joules per gram degree Celsius, change of temperature of 100 degrees, and so you just multiply across, grams cancel, Celsius cancel, and we're left over with joules, 209 joules total. So, if we were to answer the question of how much heat energy would be required for 1.0 grams of our negative 20 degrees Celsius ice, to how much energy would it take to get that to 200 degrees Celsius steam, you would have to add all of your values for steps A through E to answer that question. So the total heat is equal to the heat energy of the first step, second step, third step, fourth step, fifth step added together, and it would take 3,259.8 joules of heat energy to convert 1.0 grams of negative 20 degrees Celsius ice to 200 degrees Celsius steam. So that's all you'll have to do. Simple calculations following formulas. Let me know if you have any questions, and I will answer them. Take care.